Last example we're going to look at is finding the quotient of functions. Quotient means dividing. So question A is asking us to find actually the equation of the function as g divided by f. Yes, the order is important. G is on top, f's on the bottom. So when we find h of x, we're going to put g on top and h on the bottom. The issue here now is that we actually have a function with a denominator. This makes the graphing a little more difficult because what the fraction really is, it's really dividing. And there is sometime where dividing is not allowed. And that's when we divide by 0. So there will be a couple of places where this graph does not exist. If we make the table quickly, and if we just randomly pick a few numbers, and start filling them in, f, yes, the calculation's a little more difficult, but it's nothing too difficult. Plug in -4 for f, we're going to get 6. Plug in -4 for g, we're going to get -2. And since we're going to graph this, decimals are okay. G divided by f would give us -0.3 repeating, and since the graph is as small as it is, we'll just go to 1 decimal place. Continue the process, fill in -3 for f, we're actually going to get 0. -3 for g will also get 0. And 0 divided by 0. Well, the 0 from g doesn't matter. We can do 0 divided by 10 and get 0. We can't deal with the 0 from f. So this function is actually undefined at -3. We'll deal with what the graph looks like in a moment. Plug in 0 to f, we get -6. Plug in 0 to g, we get 6. 6 divided by -6 is -1. Plug in 1 for f, we get -4. Plug in 1 for g, we get 8. 8 divided by -4 is -2. Plug in 2 for f, we get 0 again. Plug in 2 for g, we get 10. And again, we're going to end up with 10 divided by 0. Dividing by 0 is undefined. Plug in 3 for f, we get 6. Plug in 3 for g, we get 12. 12 divided by 6 is 2. So we go to graph these, and I'm going to flip back and forth so that I have them handy. F and G should not be an issue to graph. H is going to be a little bit more of an issue, and we'll deal with that when we get to H. So when we're graphing F, I'm going to color code these, so F will be in red. We had a point at -4, 6, -3, 0, 0, -6, 1, -4, 2, 0, and 3, 6. So, as you can see, it's a rather standard parabola. g of x, I'll do in yellow. We had a point at -4, -2, -3, 0, 0, 6, 1, 8, 2, 10, and the last point, which I don't have space for, was at 3, 12. So G makes a standard line, like so. H, well, first point isn't that bad, -4, -0.3, as best as I can get that. Next point is at -3, undefined. What these undefineds mean when we have dividing functions is that is actually a vertical asymptote. Now, what a vertical asymptote is, it's basically, think of it as a line that the graph can't touch. You're holding your finger up to somebody's face as close as you can get it, saying, I'm not touching you, I'm not touching you. That's what those undefined points are. We've got another one that's coming up, where we've got a couple more points. There's a point at 0 and -1. Another point at 1 and -2. We've got a second asymptote, or undefined, at 2. Now I should mention all asymptotes on graphs are noted with dotted lines. They're not solid lines, they're dotted lines. And our last point is at 3, 2. As for the shape of the graph, well, that's influenced by the asymptotes. We can't have the graph just going straight through the points like so, because that would mean that it crosses straight through the asymptotes. A graph can never touch an asymptote, let alone cross over it. So what's going to happen on the left side is that graph is going to come and it's going to basically try to hug that asymptote, get as close to it as it can as it goes either up or down. Likewise on the right side, it's going to hug the asymptote. Now, in the middle, we don't actually have enough information for the left part of that. What I can tell for sure is that the graph is going to hug that asymptote going down because the points were going downward. What I need is another point, either at -1 or at -2, to figure out what the other piece of that graph is going to do. So I'm going to pick -2. Plug that in for f, we'll get -4. Plug that in for g, we'll get 2. 2 divide -4, -0.5. Oops. Let's try that one more time. -0.5. So we have our last point at -2 and -0.5. Get about there. So you can tell this function, as it goes left there, is going to go like so, and hug the asymptote that way.